Okay, welcome back to page 4, final page of the Algebra 3/8 shadow test, and we're straight into some simultaneous equations. So the first thing we're going to do whenever we solve a simultaneous equation is label each equation 1 and 2. That goes without saying no matter what method we're using. The next thing we're looking to try and get is the same coefficients of x or the same coefficients of y. Doesn't really matter which. I'm going to go for the coefficients of y, therefore I'll have to multiply by less. So I'm going to go for 6y, so I need to double this first equation, triple this second equation. And if I double everything in the first equation, that'll give me 8x plus 6y equals 34. And if I triple everything in the second equation, that'll give me 9x plus 6y equals 36. And I'm going to label those equations 3 and 4 respectively. Okay, I'm now going to eliminate the y's by subtracting, because if we see the same signs, we subtract. So both plus, so we're going to subtract them. And I'm going to do equation 4 take away equation 3. So that would leave me, so 9x take away 8x would leave me 1x, or just x. 6y take away 6y would eliminate it, give me 0. And 36 take away 34 would give me 2. So I found out what x is. And to find out what y is, I'm now going to sub that into one of the equations. Doesn't matter which, so I'll just sub it into the first one. Substitute, that is. 4 lots of x, so 4 lots of 2 would be 8, plus 3y is 17. I've got a little linear equation to solve here. So I'm going to take away 8 on both sides. That will give me just 3y on the left, and it will give me 9 on the right. And then I'm going to divide by 3, and that would give me 1y on the left and 3 on the right. So my solutions are x equals 2 and y equals 3. Remember, you can go back and substitute those back into both of the first equations and just check that they give you those two answers. Easy way to see whether you've been right or wrong. Okay. Same method on the next one, label them 1 and 2, and already I can see that I have my y's the same. I've got a 2 there and a 2 there. It doesn't matter that one's positive and one is negative. The only difference with this is that we are going to add them together. I'm going to do equation 1 plus equation 2, because that's how I will eliminate the y's, when one is positive and one is negative. So 2x plus 3x will give me 5x. 2y plus negative 2y will give me 0, and 18 plus 2 will give me 20. If I divide both sides of that by 5, I'm going to get x equals 4. I'm going to substitute that back into one of the equations, the first one. Okay, 2 lots of x, 2 lots of 4 is 8, plus 2y is 2. And I've got to solve this equation now. So I'm going to subtract 8, and in a minute I'm going to divide by 2. So that will give me 2y. Now 2 minus 8 is negative 6, and then when I divide by 2, y is negative 3. So x equals 4 and y is negative 3. And on the final set of simultaneous equations, these are ready to use another method called the substitution method, but I haven't gone through that in any of the videos that I've done, and we'll come across that later. So I'm going to use the elimination method again, and the elimination method kind of requires you to have the x's in the same place and the y's in the same place, and so on, and the constants in the same place. So I'm going to just rearrange this second equation slightly by adding 3x to both sides, because the difference between this and the first equation is that this is on the wrong side, if you like. So I'm going to add 3x to both sides, and that would give me 3x on the left plus y equals just 3.5. And I'm going to call this equation 2. Okay, and I'll write the other one just over a little bit so that it's above, and hopefully now you can see that things are in the right place. Okay, now I'm going to try and get my y's to be the same again, just coincidence that I've gone for y each time, and to do that I need to double this second equation. Okay, so that would give me 6x plus 2y equals 7. And I'll call that equation 3. And now to eliminate the y's, I've got negative 2y and positive 2y. I'm going to add them together. I'm going to add 1 and 3 together. Okay, so 5x plus 6x would give me 11x. Negative 2y plus 2y will cancel out. And 15 plus 7 will give me 22. And if I divide by 11, x will be equal to 2. I'm then going to substitute that back into one of the equations. Let's substitute it into equation 2. It doesn't really matter. As long as you're good with negatives. Okay, so 3 lots of x, 3 lots of 2 is 6 plus y equals 3.5. When I say I've substituted it into equation 2, by the way, I'm talking about this equation 2. So y must be equal to negative 2.5. So x equals 2, y is negative 2.5. Okay. Number 13, the first 4 terms of a geometric progression are 2, 6, 18, 54. What is the common ratio? So what have we multiplied by each time? Hopefully not too hard to spot that that is 3. What is the 5th term of the progression? Well, we've got the first 4. The 5th one, just need to multiply that by 3, and that would give me 162. And the 10th term, I don't really want to have to keep going through this in my head, so what I could do is just type in the first one, first term, press equals, and then press times 3, and you'll notice it's changed it to answer times 3. Now if I press equals, that'll give me the second term. If I just keep pressing equals, that'll give me each term in this sequence. So the third term is 18, fourth is 54, fifth is 162, sixth is that, seventh is that, eighth is that, ninth is that, and finally 10th is 39,366. Okay. And the final question, the second and fourth terms of a geometric sequence are 4 and 64 respectively. Now I've already noted from question B that they've got spaces for the first 5 terms, so I'm going to write them in there. So the second is 4 and the fourth term is 64. What is the common ratio of the progression? So what are we multiplying by here? Now we could just guess a number. So it's not going to be 2, because by double 8 I won't get 64. Is it going to be 4? So 4 times 4 would give me 16. Times 4 would give me 64. So yes, that works. So the common ratio is 4. And the first 5 terms of the progression, times that one by 4, that will give me 240 plus 16, 256. And if I divide that by 4 to go backwards, that will give me 1. The other way to do that question is to say that the fourth term, so if the first term is a, the second term is a times r, third term is a times r squared, fourth term is a times r cubed, and so on. If I divide this one by this one, what would happen is that these a's would cancel out, and I would also lose one of my r's, so this would just give me r squared. Because remember, if you divide two things of the same base but different powers, you can subtract the powers. So r squared. If I do that with the numbers I had as well, 64 divided by 4, that would give me 16. So if you know r squared is 16, then you know that r is 4. Okay, so it's another way of doing it. Okay, well done. If you managed to do that, that's excellent.